Welcome to today's Spotlight in Nutrition with Dr. David Heber, MD, PhD, and founder of UCLA's Human Nutrition.
I'm Chrissy and this is Richard, and today we're going to talk about, well, this is actually going to be a deeper explanation into what the microbiome is. Generally our videos are, maybe a minute long. This one's going to be a little bit longer. This will be about 5 minutes, but if you have an interest in science, it's definitely going to be worth understanding what the microbiome is and how it affects obese people and non-obese people, and it's pretty exciting to think of what the future of food is going to be for all of us.
And Dr. Heber himself was very excited about this one. That's why this video goes for 5 minutes rather than his normal 30 seconds or 1 minute.
Well, this is Chrissy and this is Richard, and we're signing off and turning it over to you, Dr. Heber.
Hi, this is Dr. David Heber. Most of my posts are about 60 seconds long, but I read this really exciting article in Science Magazine today, and I really want to give you the details of it in a 5-minute video. So I'd like you to be patient and listen to all of this interesting information, because I think it really connects the gut bacteria to obesity. Now, in previous days, we've taken stories about the fact that you can take bacteria from an obese twin and a lean twin, put them into germ-free mice, and the mice eating the very same diet. The lean mouse will stay lean, and the mouse with the bacteria from the fat twin will become fat on that very same lean diet. So somehow the bacteria extract more energy from the diet. Well, now a new study in science helps us to understand this better, and I want to take you through this slowly. It's a little bit complicated, so listen carefully. Let's take a look. Well, first of all, the story starts with the fact that most people who are obese have too much going on in the way of immunity. They have fat around their intestine, their immune system is upregulated, and inflammation results, which leads to diabetes and heart disease and other conditions. However, what it turns out is there's also a deficiency of immunity, and the deficiency is a special kind of antibody called immunoglobulin A. And what the immunoglobulin A does here is to block the uptake of fat into the body. There's a protein called CD36, which is a marker of fat uptake. Now, what happens is if you inhibit this whole normal immune mechanism, and you can do this genetically in mice, what happens is this good, healthy bacteria disappears, and it's taken over by an unhealthy, mobile bacteria that's called Desulfovibrio. The good bacteria is called Clostridia. And I won't go through all the experiments, but they pretty much proved that by taking this bacteria, you make things normal, and this is the bad bacteria. Now, what happens in humans is obese people have a high amount of this same bad bacteria called Desulfovibrio and too little of the Clostridia. And there have been a couple of experiments where we put probiotics in, mostly with another bacteria called Akkermansia, and what that does is it enhances the immune function and helps with weight loss. Now, here's how it works in detail. So you have these T cell helper cells that then cause the B cells to excrete this antibody, which stabilizes the ability of Clostridia to inhibit fat uptake. If you get rid of the Clostridia, these other bad bacteria come in, and now fat uptake increases. So you might ask yourself, why would you want increased fat uptake? Well, it turns out this is another one of those adaptations to starvation. If you were starving and suddenly your bad bacteria overtook your good bacteria and you became immunodeficient and had too little IgA, this adaptation would help you take up more fat so you could survive starvation. This is Dr. Dave Heber. Thanks for listening for this longer story.